Hi, this is the EGD guy again. Just before we start with today's lesson, I'd just like to show you that by using sketches to do isometric circles, um, use the same method that I've explained to you in video 9. Just do it freehand, and in this case here I've pointed out that each point from where I actually draw the arc. So it's the same principles, and here I've just done a pipe or pipe, whether it's a hole through. On this side here, I've used that, and then obviously a smaller block for the inside circle to create that hole through the shaft. Here on this one here, I've just used the same principle to draw a Pritt stick using the same principles. As you can see, I've changed the paper. So today's lesson is actually going to deal with auxiliary views, and the auxiliary view is normally have to be drawn by if I want to take in this case here, a hexagon into isometric, I have to draw the two-dimensional drawing of the hexagon first, then block it, and you can see here I've done the construction. Remember, your constructions are very important because sometimes if they say just draw the whatever shape they give you, then you don't have to show construction. But if they say show all constructions, then you must make sure that you have the ability to do the construction. Once I've done the construction, I've blocked the whole shape, because as you can see, the distance from 2 to 5 is not the same as from that line to this line. And this is why you've got to do an auxiliary view. And auxiliary views will normally have to be drawn for any shape that has got an angle to it, and you want to take that shape and move it into isometric. You have to do an auxiliary view of it first, and this is what I've done. The first one is the hexagon, and I've labeled it so that you can actually see exactly how I am going to transfer it over to the isometric block. Now, if you can remember, I'll have to just move it every now and then. The object is now, or the important part of transferring this shape over to isometric is the block is actually becoming the important part. In other words, A, B, C, and D becomes important. Now I've worked out, I've bisected it, or I've got the center there and the center there. So on this shape over here, I've also got the center. As you can recall, I've mentioned that I prefer to work from the center of something. And in this case here, what I'm going to do is I can take the measurement, and just before I continue further, is I want the baseline AD to be at the bottom over here. So you can see that I've placed it in such a way that I want AD at the bottom. What I would do now is, there's two ways of doing this. You can either, first of all, what you have to do is take the length of the half of the hexagon, in other words, from the center to 2, and then obviously on the center to 2, and make a mark there so that you can see it. Sorry, my hand was in the way. So that I can see that that is the size. I'll do the same from 2 to 5, 2 to 5, and then from the center up, I have to change my radius, and from here it will go from there to there, and from here to here. then obviously if I draw a 30-degree line through there, and there, that will give me the exact block that I've got here. In other words, A, B, C, D. So the block is the important part. Once I've done that, I can now either work from the center or I can work from A to 1, because I've got A and 1 is on the same line. But as I said, I prefer to work from the center, and I'm going to set my compass from the center towards, in other words, 1 will be marked off towards A, and 6 will be marked off towards D. In other words, from here to there, and from here to here. I do the same at the top, because those measurements are actually the same. And from the center towards 3, and from the center towards 4. 2 and 5 is on the center line, so I don't really need to go and measure that because it's already there. And all I need to do now is to line up 1 to 2 as it shows here. 1 to 2, and I'm going to make it dark so you can see it nice and clearly. 1 to 2, then 2 to 3, and you can see that something is happening here, and this is why this line 2 to 3 is shorter than 1 to 2, but it's because of the way that it is maneuvered that in isometric it looks as though it's shorter, but it's not really. Here, if you measure it, it will be, but because of the angle at which we are drawing it, it looks as though it is shorter in isometric. And that is why we've got to draw the auxiliary view first. In other words, the auxiliary view helps us to block it and then take the block and copy the block first, and then from there we copy the actual hexagon. Now we can give this depth, or it can be a hole going right through, and this will normally be present in an isometric drawing, where they will give you one of the polygons, or sometimes a dovetail, referred to as a dovetail, but I've got an example of that as well. So for instance, I have to give this depth, then what I will do is I will draw a line down at whatever the length is, or the depth is, and that is all. That's the only 2 corners that I will see. Now I can use the sliding set square method here. In other words, line that up there, and then sliding it, it's moved, so always go back to your original one that you want to draw parallel to that line. There. Now I want it to go onto this one, so I will sliding set square method, use that there. This one over here, let me just change my set squares, line it up, and there it will give me a depth. So you can see that sliding set square methods, which is part of constructions, and the construction of the hexagon as a polygon, one of the polygons, do the construction and then block it, and then use the measurements of A, B, C, D back to A as your block on the isometric drawing under this at 30 degrees, and continue like that. Now I've also done one in the for the pentagon. I've blocked it, I've labeled it so that you can keep track of what I've done. Now I'm going to try and put it in such a way that you can still see at least part of the pentagon. And as you can see, sometimes you don't need to do the full construction, you only need half. But remember, if you use half, you've got to be very careful to transfer, for instance, the distance from there to there as a double size, because you also need it on the other side. I've already transferred my block E, H, G, and F, or E, F, G, H, doesn't matter which way you mark it. And my baseline on the EF side of the block will be at the bottom, and I've already stepped off from there, from the center to 1, from the center to 1, from the center to 2, so I can actually darken that. There's my line, and from there I've got to go be careful here, because if I draw a line through 5, 3, that is not necessarily the center of the block. So just be careful that when you transfer this measurement from there to there, that when you draw your polygon in here, your pentagon, that you go to the correct mark and not to halfway. And here you'll see that that will go to there. And again, you can see that some of the sizes doesn't look as though it's right, but because it's an isometric, it is correct. And we've used the sizes from the auxiliary view, so it is correct. That one unfortunately is going through the 5, but you can see that even here, if I wanted to go and show that it goes right through, all I need to do is to draw a line at 30 degrees, and that will show that it goes right through. The last one that I've drawn is the it's not often asked, but sometimes it can be part of a question, especially in the higher grades, where I just want to try and move it so that you can see it. There it is. It's called a dovetail, and in woodwork we use that quite as a joint, to join pieces together, or on the corner of a drawer or something like that. Now what I've done here is I've drawn it in 2D. In other words, as you see it, it's STUV, and the angle, because there's an angle involved, we have to draw it like this first, then block it, and there's my block, which is 1 to S and 2 to V is the same distance, to give me the same angle. And then what I did is I copied 1 to T as the height, and T to U is the length, and then U to 2 is the same as 1 is to T. And there's my block. So I've blocked it, and now what I'm doing is I'm drawing a line down there after I've blocked it, and I measure from 1 to S, from 2 to V, and that in itself will give me the angles that I require to draw in the shape of the dovetail. Yeah, I've drawn that line in there. I've drawn this one from S to T, and just to show that it is a dovetail, I'm going to darken this part here to the corner and the top line. And if I want to show that it's going in, but it's only a certain depth, I want to just remove the V here so that you can see. I'm just going to put a V a little bit further back. That's V there. I'm going to take this in at whatever, say for instance 10 millimeters. Then what I will do is I'll mark off the 10 millimeters and draw a line, and then I've got to use my sliding set square method to get that angle, and there it is. And there is a dovetail onto the end of that block. So that concludes today's lesson. I hope you have learned something from this. And remember, practice, practice. That's the only way you can really get to grips with this type of drawings. And you have to remember that the block becomes important, and only after you've drawn the block in the position where it has to go, then the actual shape becomes the important part. Thanks for watching.